Hi all, welcome to the video lecture on cryptography. This video is about the Diffie Hellman key exchange algorithm. So in public key cryptography, we have asymmetric keys that is used for encryption and decryption. And we saw an example for the utilization of the different keys. So in that is the RSA algorithm in the previous video, and this video talks about the Diffie-Hellman key agreement protocol. So there are two people. The communication always happens between two people. So there they have to cryptography is changing, transforming your actual data into some other format, and at the receiver side, the converted data has to be brought back to the original state. Then only the receiver will gain the actual meaning of the data being sent. So in this concept, now in Diffie-Hellman key exchange algorithm, the key is exchanged between a public key is exchanged between both the users, and with that public key information, they both will be calculating a secret key that will be same, so that it is helpful to be used in encryption as well as decryption. So here this Diffie-Hellman key exchange algorithm is based upon the discrete logarithm context, and this is not known for successful attack strategies, which means it is that much secure. It gives us a secure key transfer strategy. And it takes two large numbers. One is a prime number, another one is a primitive root of prime. And they both are publicly available numbers for the sender as well as the receiver. And the p-value is at least 512 bits. Then what happens? Both the users will be calculating the price as you are seeing in this picture. So there are two persons, Alice and Bob. So the first, Bob is creating a private key, and with the private key he is generating the public key. Same way, Alice is having a he is choosing a private key, and with the private key she is generating the public key. Now both the parties are sharing their public key. Their private key is not known to the other person, only they are sharing the public key. So after they are sharing the public key, they both are calculating the secret key on their own. Algebraically, it is going to be equal. That's the concept. So the applications of Diffie-Hellman key exchange algorithm is shown in this PPT. So this has been utilized in many protocols like SSH, TLS, and public key infrastructures likewise. Now let us solve an example of how this key agreement process is happening, or key exchange is happening with the help of Diffie-Hellman key exchange algorithm. So let us do an example. Consider there are two members, Alice and Bob. So first, they both are commonly choosing a prime number, the large prime number, and the generator base that they are agreeing with themselves. So the large prime number is said to be is denoted as P, and for example, it is 23, and the generator or the base value is 5. Okay, and the very first step is they are choosing, they are randomly choosing a private key. Okay, they are randomly choosing a private key, and it is denoted as I'm giving the notation as XA for Alice private key, which is 4, and Bob's private key is 3. Okay. So with this chosen private key, they both are calculating public key for themselves. For the public key, I'm giving a notation called YA. It is calculated using a formula, that is G to the power the private key modulo the given large prime. So same way here, the public key of the Bob is calculated using G to the power the private key of Bob mod P. Okay. So substituting that G is 5. So 5 to the power XB is 3 modulo 23. Same way here, 5 to the power the private key is 4 mod 23. All right. So now the public key is calculated by both the parties, and the answer of this is I have calculated, and we have done this exponentiation and the power value calculations in the earlier videos itself. So YA we will have 4 and YB we will have 10. So now both the parties will be exchanging these values. Okay, that is the important part. They are not exchanging the private key, they are exchanging only the public key. Now what happens? They both are going to calculate the secret key on their own. So the secret key calculation formula is K is equal to, just now we have got the public key of Bob. So with that YB and the secret key of user A is used, mod P. And next, for the secret key calculation of user B, it has just got the public key of A, and with its own private key, it is modulo with B. So when we substitute, it is going to be 10 to the power 4 mod 23, and here it will be YA. It is 4 to the power XB, it is 3 mod 23. Okay, so you all must be knowing that it is going to be 4 zeros modulo 23, and this should be 4 fours are 16, 16 fours are 64 modulo 23. So 64 modulo 23, if you do it in the calculator, we'll be getting 18. Same way, 10,000 modulo 23 also we will get same thing. Okay. So here comes the interesting part. It didn't share much information. They both shared only the public key. So there was a secret private key selected by both the parties. With that, it is calculating the public key at every end. And then finally, they are calculating the secret key. So with secret key, they achieved that without sharing the actual key, they were able to calculate the same secret key. That is the advantage of this Diffie Hellman key exchange algorithm. So this will be helpful in public key cryptography, as we have seen that the PKI public key infrastructures and then the protocols like SSL transport layer security. The Diffie Hellman key exchange is a popular algorithm that's helpful to share something, especially the important keys between the both the parties, the sender and the receiver. Okay, this is the significance of Diffie Hellman exchange algorithm. Stay tuned for more videos.